All right, in today's mini lecture, we're going to be solving rational exponent equations. So when we say rational exponents, we're really just talking about an exponent that's written as a fraction. For example, here we have x raised to the 3/2 power. So the exponent here is a fraction, 3/2. Therefore, it's a rational exponent. It's an equation because there's something on the other side of the equal sign, and we're going to solve for x. So we have 27 equals x to the 3/2 power. We're here to solve for x. We have a rational exponent. So I'm just going to write it over again. And now take a look at it and say to myself, the key here is to try to get rid of this rational exponent. So how could I do that? Well, I could raise this x to the 3/2 to the 2/3 power, right? So all I'm doing is taking this rational exponent and flipping it. So 3/2 times 2/3, and if you think of that in your mind or do some work on the side, 3/2 times 2/3 will get you 6/6, which is just 1, and that's great. X to the first power is just x. So I do that, but what I do to one side, I must do to the other side, right? So I have to raise this 27 to the 2/3 power as well. Well, luckily in a previous lecture, we looked at how we can change something with a rational exponent to a radical, right? So that's in a previous lecture, in a mini lecture that we have. So 27 to the 2/3 power. That becomes 27 under the radical. That 3 there in the denominator is our index. And that 2 is what we raise it to. So this is by convention, right? When we have a rational exponent, we can always change it to a radical, where the denominator is your index, the numerator is what you raise it to. And we've already said over here, 3/2 times 2/3, right? Because if you remember properties of exponents, a power raised to a power, you multiply those exponents. That makes 6/6. 6/6 is just 1. X to the first power is just x. So now we can go ahead and evaluate this cube root of 27. So what number times itself 3 times will get us 27? 3 times 3 times 3 is 27, right? So 3. And let's not forget, it's raised to the second power. So 3 to the second power is 9. So our x is equal to 9. Let's go ahead and try another one. We'll say m to the 3/4 power is equal to 27. All right, I'm going to rewrite it again. M to the 3/4 power is equal to 27. I never like to just start on my original problem, because then when it's time to go back and study, I won't know what the original problem is because I've marked all over it, right? So m to the 3/4 power is equal to 27. So I can raise both sides to the 4/3 power. I'm just flipping that 3/4. And then I have 27 to the 4/3 power. 27 to the 4/3 power. So m to the 3/4 power raised to the 4/3 power will give me m. And then I'll have the cube root of 27, and I'll raise it to the 4th power. So m is equal to the cube root of 27 is just 3, and 3 to the 4th power is 81. So our m is equal to 81. Next problem. X to the negative 3/2 power is equal to 1/729. All right, we're going to use that same technique we've been doing. So x to the negative 3/2 power. Here, we're going to raise this power to a negative 2/3 power. And see how I flipped it again? The 3/2 flips to 2/3. And I'm raising it to a negative because I know when we multiply a negative times a negative will make my exponent positive, and it will be a positive 1, right? Because 3/2 times 2/3 makes 1, and I want it to be positive, so that's great. and then this is equal to 1 over 729 to the negative 2/3 power. So what I did to one side, I had to do to the other side of the equation. So this becomes just x to the positive first power, which is just x. Here, when we have a negative exponent, right, this entire quantity flips. So instead of 1 over 29, this becomes 729 over 1. Or I can just leave it as 729, right? And now it's to the 2/3 power. So that negative exponent flipped this quantity inside of the parentheses. Understand that. So once it flips, I don't need to use that negative anymore because the negative flipped it. So now I'm just raising the 729 to the 2/3 power. So this rational exponent changes this into a radical 729. And by convention, in definition, the 3, the denominator, is the index. The numerator of 2 is what we raise it to. So this becomes the cube root of 729. That would be 9. 9 times 9 is 81. 81 times 9 is another 729. So 9. So 9 to the second power gets us 81. So x is equal to 81. All right, we'll try another. Our problem here is n minus 27. So this entire quantity raised to the 3/2 power is equal to 64. So same process. I'm going to take the n minus 27 raised to the 3/2 power, raise that entire quantity to the 2/3 power. What I do to this side, I must do to this other side. So I raise that side to the 2/3 power. So again, when I raise a power to a power, I multiply the exponents. 3/2 times 2/3 makes 1. So all of this is n minus 27 to the first power, which is just n minus 27. And now this is 64 to the 2/3 power. So what does that do? That makes this a radical 64. The denominator goes in the index. The numerator is what we raise it to. So n minus 27 is equal to the cube root of 64. We do that first. Cube root of 64 is 4, right? 4 times 4 is 16, times another 4 is 64. And then we can't forget that we're raising it to the second power. So n minus 27 equals 16. And now we just have a simple linear equation to solve. We solve for n. Add 27 to both sides, and we get n is equal to 43. All right, so all of that was solving rational exponent equations. If this helped you, make sure you click the like button, share with whomever you need, friends, family members, classmates, and don't forget to subscribe, and feel free to shoot me an email if you need any topics reviewed.